Hi everyone, welcome again. In this video, we are going to learn Spring JDBC. Spring JDBC is a Spring project dedicated to JDBC connectivity. What that means is that we can create a Spring project using Spring JDBC and we can talk to the database. So if we have a backend data store, for example, MySQL or Postgres, we can write code in Spring that can fetch the data from a table or that can write data or update data in a table. So that is what we are going to do with Spring JDBC. Now if we talk about the Spring project, so there is something called Spring Data. If you see on the left hand side in this menu where we list all the Spring projects, so you can go it from here, go to the Spring home page and view all projects, and here Spring Data. So Spring Data is a big project. It has a huge support for database connectivity, and you can see there are different projects like Spring Data JDBC, Spring Data JPA, MongoDB, Redis, Apache Cassandra, Couchbase, Elasticsearch. So there could be any data store that we may want to use, for example Couchbase or Cassandra. Then there is a Spring project that simplifies the connectivity part. So what we are going to do in this and the next couple of videos, we are going to focus for now on the Spring JDBC, which we can see is listed here. So under the Spring framework, there is this section called data access. And we are going to focus on this one only. Now, Spring JDBC internally uses JDBC API, which is Java Database Connectivity. So if it internally uses JDBC API, why not simply use the JDBC API directly? Why do we need to use a Spring project, for example, Spring JDBC, to talk to the database? Now, reason behind this is that the philosophy of Spring is to make everything easy on top of Spring Core, which actually enables us to use dependency injection and inversion of control principle in the form of Spring's IOC container. So Spring JDBC takes the benefit of Spring Core, or also known as Spring Framework, and it simplifies the whole JDBC connectivity part, and it enables us to write the simple logic in simple lines to, let's say, fetch the data from a table. What you see here is a code sample from official JDBC documentation, and it shows how many lines are required to create a connection basically. So you can see that we have to initialize the properties, then set the properties, and finally we have to use the driver manager to get the connection. So that's how we generally create a JDBC connection, which is the first step. Then this code must also look familiar to you if you have ever worked on JDBC. So this code is an example of reading data from a table. So here we have this query, simple select query. Then from the connection, we create a statement. Then we call the execute query to actually execute the query. We get the result from statement in the result set object. Then we iterate on the result set and get the values accordingly. That's how we fetch the data from the database. Here is an example of update query. So notice the overall steps. First, we need the connection, then we create the statement. So here we are creating the connection, then here we are creating the statement. And this time the query is using placeholders. So we set the values dynamically. Then we are calling the execute update method to actually run the update query. Then the code is committing the connection, closing the statement, and in the finally block, closing the connection to release the resources. Now that is usually we write the JDBC code. Now Spring says, I will simplify everything for you. All you need to do is you need to provide me the query. So here we see the segregation of responsibilities between the developer and the Spring JDBC. On the left, we see the action. So let's say define connection parameters. This is something that we need to do. Open the connection will be handled by Spring. So Spring will open the connection. It will prepare and run the statement, and it will iterate on the result set. After the execution is complete, if there is any exception, it will be Spring Framework who will process the exception handle the transaction, and close the connection. What we need to do is we need to define the connection parameters, then specify the SQL statement. We need to write the SQL statements, pass the appropriate values to the query if we are using, let's say, placeholders. And then when Spring is iterating on the result set, we will write the logic, what we need to do in each iteration with the result set. So as you can see that when we are using a Spring JDBC project, we don't need to open the connection and we don't need to do anything with the result set or closing the connection. So all these things will be handled by the Spring JDBC. Now that we have a little bit idea what Spring JDBC is all about, let's start with setting up the code base and let's see Spring JDBC in action. Hi everyone, welcome again. In the last video, we covered the basics and the overview of Spring JDBC, and in this video, we will see how to set up the code base, then how to connect to the database and read and write data from that database. So I'm going to create a new project and set up everything from scratch. I'm using IntelliJ IDEA, so I'm going to hit new project. Then name this project Spring JDBC demo, JDK 19, and additional properties. This is not required. Go to the advanced setting, group ID, okay, artifact ID and snapshot. Now hit create. So this is going to create a simple Maven project. And here we have the pom.xml. And all the properties have been set up correctly. All we need to do is we need to add the dependencies. So what all dependencies do we need? Let's see. The first dependency that we need is for core Spring framework, which is Spring context. Second thing that we need is Spring JDBC, which is required for JDBC code, the actual code that we will write to connect to the database. The third dependency we need is for database connector. So because we are going to use MySQL, we need a MySQL connector. And the name of that dependency is MySQL connector Java. So let's Google these dependencies and let's add these dependencies to pom.xml. So here we first Google Spring context Maven dependency, go to the first link and the latest version, copy the code and add a dependencies section. And in this section, we will add the dependency. So this is the first dependency. Now we need to search for Spring JDBC. So we can search that here only. And this is the first one, the updated version. We can copy this one. Okay. And the third one as well, MySQL connector Java. And this is the one that we need, MySQL connector Java, the updated version, and copy the code. Now that we have all the required dependencies, I'm going to reload the project so that Maven can download these repositories. This will take a couple of seconds to download the libraries. And if we go to the external libraries, we can see all the required dependencies. We have the MySQL connector and then the JDBC one, and then all the dependencies for the Spring framework, which is Spring context. So now that we have all the dependencies, let's set up the base project. So let's add the source folder first. We have src main Java and we can add a class first, runner. And then I'm going to initialize application context And right now we don't have any config file, so I'm going to leave it empty. And if we run this now to check the basic setup, we see no errors, so which is good. Now the second thing that we need is the database. We need to run a database so that we can talk to that database. I'm going to use MySQL. So you need to install the MySQL first on your local if you're going to follow along. Otherwise, you are free to use any database. The only thing is we ultimately need the JDBC URL, the username and password. And so if we have those properties, we should be able to set them properly for the Spring. So I'm going to run MySQL on my local first so that I can connect to it. In order to run the MySQL, I'm going to go to the bin directory from the program files where it was installed, and I will say run it as root. And then I'm going to open the workbench. And let's create a new connection. Let's name it Spring JDBC demo, and test connection, my root password. And it says successfully made the MySQL connection, which means the MySQL is running on my local. Click OK. And this is basically the MySQL client, the UI client, which we will use to create the database. For example, let's create a new database. Spring JDBC, apply. And this is the new database. Right now, it does not have any tables. So let's add a new table that we are going to use in the demo. So create table. Let's name it students ID, and it can be primary key, first name, last name, and age. We can change the data type from the UI. Let's set it int, and this is going to be a simple column sufficient for the demo. So let's hit apply and create this table. And so on the left hand side, we see the table in Spring JDBC database, and select rows, and right now this is empty. So this table is right now empty and we have that database running on our local. Now let's go back to the IntelliJ and write the code to talk to this database and this table. Now in order to connect to a database in Spring, we first need a data source. So we need to create a data source bean that we will inject in the DAO classes where we will create JDBC template and name JDBC template to write and execute the queries. So first the first step is to create the data source, a bean for the data source. So to do that, I am going to create a config file. In the config package, app config, and because this is going to be a configuration file, so we'll annotate it with @configuration. Then we'll create a bean using @bean annotation, and this bean will return the data source. All right, now we need to create a bean for the data source, and for that we will be using driver manager data source. And then we need to set the properties. Set driver class name, set username, set password, and set URL. And then we'll return this data source and also annotate this method as @bean so that the Spring container can create a bean for data source when the server starts up. Now we need to fill these properties. We need to basically give these properties. These four are the required properties for any database. This is the driver class name. That is going to be the connector class. Then the username and password that this code is going to use the credentials to connect to the database. And URL is where this code is going to find the actual database. All right. So let's set these properties. First, the driver class name. The driver class name that we use is com.mysql.cj.jdbc.driver. Now, the databases have different drivers. For example, if you are going to use Postgres, the Postgres database will have its own driver. So we always Google the driver class name for the database that we are going to use. For MySQL, this is com.mysql.cj.jdbc.driver. Then the username, because I'm going to use the root user, so that's going to be the username for me. The password is the password that I set for the root user. So that is my simple password. And then the URL to find the actual database. And this follows a pattern. So it says JDBC :MySQL, the database provider, in this case MySQL. Then the URL, because we are running MySQL on our local system, so that's going to be localhost. MySQL runs on 3306 port, and then the name of the database. So that is, in our case, is Spring JDBC. And that's it. Now in the runner class, we need to pass the app config where we are initializing the application context. Okay. So that should be it to create the data source. Let's verify the setup by running the code. And there are no errors. It means the Spring container was able to identify and read the configuration from app config, and it successfully created a bean for the data source. Now that we have the data source, all we need to do is we need to create the JDBC template, and we can simply start writing the queries. All right. Although in a real project, we have the DAO layer, which is the data access object layer, where we write the repositories. That means the DAO classes annotated with @repository. So this will be a series of, for example, component classes, then service, then repository. But because this is going to be a simple example, so I'm going to add a new class and write all the queries in that class only. All right. So I'm going to still name it, for example, DAO package, and a Java class, student DAO. And let's annotate with repository, and simultaneously first let's set the component scan as well. So what I've done, I have refactored the package name, and now everything is under this root package com.thecode alchemist. And I did that so that I can use the root package in the component scan. So after putting everything under this root package, I've given the root package name in the component scan so that Spring container can scan all the classes under this sub package and all the sub packages. So Once done, let's go back to the student out that we created. It is annotated with repository. The next step is to create the JDBC template in the DAO class. So we'll define a variable with name jdbcTemplate, and we'll also create a constructor like this. Now, in order to create the JDBC template, we need access to data source. And if we go to the app config, we see that we already have a bean for data source in the app config file. That means when server starts up, the Spring's IOC container will create a bean for the data source. Now we can access this bean. We simply need to inject this bean in student.dao. To do that, we will use @auto_var annotation to auto-var the dependency of data source like this. And once we have the data source, creating the JDBC template is straightforward. All we need is we need to call the constructor of the JDBC template and pass this data source, and done. So when the server starts up, Spring's IOC container will scan this app config file. It will create a new bean for data source. Then when it initializes the student DAO, it will see that the student DAO is dependent on JDBC template and that we are auto-varying the dependency. So it will inject the data source to this DAO class, and in the constructor, then a new instance of JDBC template will be created. We can verify the object if we add a new method in this class, let's say test queries. We can simply print the object to verify that the setup is working fine. All we need to do is we need to call this method. So we'll go to the app config, runner.java, and we'll create or get a new object of student.dao from the application context using getBean method. And then we can call the new method test queries. So let's run the program and let's see if we are able to print the new object of JDBC template properly. And we see this message on the console. That means in the student class, we successfully created the JDBC template using the data source. Once we have the JDBC template, we can easily do DB queries from the Java code. Now let's quickly go to the MySQL panel and verify that the students table is empty. If we execute this query, we see no data. We are going to explore JDBC template to understand how do we fire, how do we execute insert and update queries. So let's do that. Now JDBC template has lots of methods related to query and to execute update and insert statements. One such method that we are going to see is update. So you see this is the update method. It accepts a simple SQL query. Then we have another variation that accepts the prepared statement creator. Another variation says that I will accept the SQL, then another parameter of type variable arguments. Then we can pass the SQL statement and an object of prepared statement setter. So there are different variations of the update method. We are going to see a couple of versions one by one. So let's start with the simple one, update, where we can pass a simple query. So let's say we have to insert the data in the table because right now table is empty. So we are going to insert some data. We'll say insert into table name and values. The first column is ID. So let's say 101. Second column is first name. Like this. Last column, the last name is last name. And then the age 15, which is an integer value. And now if we run the program to insert this data into the table, we see the code execution is complete. Let's go to the MySQL panel and select again, and we see that the data has been inserted into the table. So that's how simple it is with Spring JDBC. And if you notice, we don't need to create a new connection. We are not creating any statement. We are simply using the update method and passing the SQL directly to this update method. Everything else is done by the Spring framework. It is creating the connection. It is creating the statement, uh, executing the DML statement in this case, and closing the connections and statements accordingly. In this example, we passed the values directly to the query, but that's not how we generally do it, because most of the time these values are coming as an input to the query. Maybe some other code is calling this test queries method and passing all those values. So what generally happens is we write queries like this: jdbcTemplate dot update, and let me copy the query. Last name, and age. So that's how we generally pass the values to the queries. These values are simply are variables that will be defined, let's say, as a method parameter or as part of the method body. So right now I'm not going to create these variables. But one thing that we need to remember is that these type of queries are prone to SQL injection attacks. So the recommended way is to use the placeholders. Instead of appending the values in the query, what we do, we use the placeholders and then we pass the values to the placeholders separately. So instead of passing the values like this, which is hard-coded way, or using the variables like this, what we are going to do is we are going to pass four placeholders. We will define four placeholders using question mark. Okay. Now, how do we pass values to these placeholders? Now, update method has another version which says that the second argument or the second parameter can be a type of variable argument. Now, variable argument means we can pass any number of values. So we'll use that variable argument to pass the values to these placeholders. Okay, so the first value is going to be ID. In this case, let's say 2. The second argument is for the first name, which is going to be first 2. The third argument is for the last name, so let's insert it last 2. And the last argument is for the age, which is integer, so I'm going to pass, let's say, 16. So this is the insert query. The second insert query is, it has 4 values for 4 columns, but this time we are using the placeholders using question mark, and we are passing the values separately as variable arguments. So let me comment it so that we don't insert the duplicate data. Let's verify the same. And now we have the second row, this one with ID 2, first name, last name, and age that we provided here. All right. Let's move on. So this time we are going to use another version of update method, which is this one, prepared statement creator. So we saw in the previous example that we were using placeholders and passing the values like this. Now there is a better way, you can say, if we want to use the prepared statement creator. So what I mean by that is we need an object of prepared statement creator. And here we can first create the prepare statement, then the update method of the Spring JDBC will use that prepare statement to execute the queries. All right. So we say prepared statement stmt equals to con dot prepare statement, and then we'll pass the query using the placeholders like this. So we are saying that create a prepared statement for this query. Now we need to pass the parameters. To do that, we use statement dot set methods. So prepared statement has setter methods to pass the values or to set the values for these dynamic placeholders. Now, the first argument or the first index is for id, so which is integer. So we'll use set int method, and this is going to be the column index, and the second parameter is going to be the actual value that we want to set for this placeholder. Now what we want to do is we want to set id as 3 for this record, so that's going to be the second argument. Now coming to the second placeholder, which is for the first name, we'll use set string because it's a string data type. Then the parameter index, the index of second column is 2, so that's going to be the value 2. Next is going to be the value, which is in this case, let's say first 3 for the first name. Similarly for last name, we want it to be last 3. The index for the last name column is 3, and the last column whose index is 4 is for age, so we'll change the value to, let's say, 17, and this is going to be set int, and then we can return this statement like this. So what we are doing, we are creating a prepared statement defining 4 placeholders. Then for all these placeholders, we are accessing them by index. This is the first column, second column, third column, fourth column, and then we are setting or passing the value. So this is the id equals to 3, first name is first 3, last name is last 3, and age is going to be 17. So let's run the method. It executed successfully. Let's verify the output, and we see the record has been inserted. This is the new record that we just inserted. Now we don't need an anonymous inner class. What we can do is we can simply replace it with lambda like this. So that's how we use prepared statement creator. So we create the prepared statement and then pass the values using the prepared statement. So till now we have seen how to insert the values into the table. Let's see an example of how to update the values. Now to update the values, we can use the same method, update. So we can use the update method. The only difference is this time the SQL is going to be the update SQL. Till now we have been using the insert SQL, but this time we can use the update statement. Everything else is going to be the same. So I'm going to use a simple example, a single method call, and whatever we discussed for insert statement, for example, passing the values directly in the hard-coded way or using the placeholders or using the prepared statement applies to the update statement as well. So let's see a quick example of how to trigger the update query. So first argument is going to be the SQL statement. So we say update table name set column. So I'm going to update the first name column. Let's use the placeholder where id equals to this. Okay. The second argument is going to be the variable arguments because we need to pass the values of these placeholders. So the first placeholder is first name. So we'll provide the updated value. Let's say this one. And the second placeholder is for id. So we need to provide the id of the record that we want to update. So I'm providing 2. That means with id equals to 2, this first name will be updated to first 3 modified. Right now this is first 2. Okay, let's run the program. And if we trigger the query, we see that the record has been successfully updated. So there is no difference. There is no different method. The method remains the same, update. The only difference is the update statement instead of insert statement. So that's how we insert the data. That's how we update the data using JDBC template. Next, we are going to see how to read data from the database. So let me comment this query and let's use the read methods from the JDBC template. So to read data from the database, JDBC template has methods related to query, which means that if we explore the methods of JDBC template, we see these query methods. These query methods can be used to execute a select query on the table and get data from that table. So for example, this query method takes a SQL and an implementation of result set extractor. This one takes the SQL and an instance of RowMapper. So there are variations, different variations of the query methods. Now, if we scroll, we have methods like query for map, query for list, query for object, query for row set, query for stream. That means we can execute the query and get the stream of results. So we'll start from the simple query for object. Now query for object method has quite a few variations. So if you see, all of these methods take the SQL, then we pass the class type of the return type. By default, it returns an object. So we can pass a class type so that we don't have to typecast manually. Then we can pass the RowMapper so that we can map the record using RowMapper. We will see how to use RowMapper. Then let's say if we are using a placeholder in the query, we can use this method which takes the SQL, the required type that this method will return, and the values for those placeholders. And similarly, the values for the placeholders when we are using RowMapper. So let's start with this one. First, it takes the query. So we can simply say select first name because we need a single value from students where ID equals to 2. Okay, so if you see, the return type of query for object is object, and we need this string because first name is string. So what we can do, we can pass the class type here, string dot class, and now this object will return the string. And we can print this output, and let's run the program. So we see the first name of the student with ID equals to 2 is first 3 modified. And if we go to the database and execute the select query, we can see that the first name is first 3 modified for the ID equals to 2. It means the code returned the correct value. For the same method, we can also use the placeholders. Here we are passing the value directly to the query, but we can use the placeholder as well. So let's do that. Now, if we want to use the placeholder, there is another variation of this method where it takes the third parameter as well. So the first parameter is SQL, the parameterized SQL. The second parameter is the class type of return type. And the third parameter is a variable argument where we can pass the values for all the placeholders. So because in this query, there is a single placeholder for ID, so I can pass a single value. This time, let's pass the ID 3. And instead of first name, let's take the last name. Running the program. And we get the last name last 3, which indeed is the last name for the ID 3, this one. Okay. Let's say query for, we have methods like query for map. So when do we use query for map? Let's see that. Now we can execute a select query again. And this type, we are asking for all the columns. So we are saying select star from students. This will return a map of string and object. For now, this is fine. And what we can do, we can simply print this map. Import the map, comment these calls. All right. So we are using query for map, and we passed a SQL to get all the students, and we are printing the result in the form of map. And we got an exception which says that incorrect result size, expected 1, actual 3. So the thing is, query for map will work only if there is a single record that a query will return. So we cannot fetch multiple records with query for map. So we need to restrict the result set to a single row. That means we can use where id equals to, let's say, 2. Now this query will return a single record. So query for map can be used with a query that returns a single record. Now for that single record, what it does, so for this query, map will have 4 keys: ID, first name, last name, age, and their corresponding values. So let's run the program now. And we got this map where the keys are the column names and the value of that key is the corresponding value from the table. Let's move on. This time let's use another query method, query for object. We have seen query for map we have used. This time let's use query for list. Let's understand what query for list will return. So if we run this query, for example, the query for list method will return 2 records first of all. So the list would have 2 records, and each record will represent the row in the form of map. So we have already seen what query for map method does. It returns a map where keys are the column names and values are their corresponding values. So that is same with query for list. What it does, it converts each row to a map and then it returns that list. So if we run this query with query for list, we will have the list of 2 items, and each item will be a map that represents the query. Sorry, that represents the row. So let's use that. We can say select star from students where id is greater than or equal to 2. Okay. And it will be a list of map of string and object, and we can name it rows. And if we get this printed, so first of all, see that the size of the list is 2. Now this is the first element of list and this is the second element of list. Then each row was converted into a map, same as query for map method. So what we have seen till now, query for object to get the single value from the query, then query for map to get a single row in the form of map, and query for list to get the multiple values or multiple rows from the database. We say this.jdbcTemplate dot query. Now this is the method that I'm talking about. Second method, it takes a SQL, which is the query that we want it to execute, and then a RowMapper. Now RowMapper could be an anonymous implementation or a lambda. The important thing is that we give the implementation of map_row method, and what JDBC template would do once it has the result set, the data from the database. So for each record, it will call the map_row, the implementation that we gave to actually map that row into something. Now we can use the same query because we know that it returns multiple records. This one. Now we need to provide an implementation of RowMapper. This one. Now RowMapper has a single method maprow, and we need to provide the implementation of this method. And this method is used to map a row into something, and that something is decided by us in the form of implementation of this method. And whatever value we return from the map row will be added to the result list that this method finally returns. So this is something like this: list of object. Okay, so what we are going to do in this case, because we have a student object, so we are going to return this student object from the records. So let's change the return type student, and we need to change this here and here, because now we are going to get the list of students. Now we can create a student from the data of that row in this method. So let's create a student object that we will use to populate the data. This one. So it has a constructor with 4 values. The first one is ID. So we can use result set to get the value directly. First column is ID. Then second column is first name. So we are using result set.getString. Then we'll fetch last name, which is the third column. And finally the age, which again is an integer, like this. And we can simply return this object from the maprow method. So what it will do, for each row, it will call the maprow, and we are using result set to get the values by column index, first index, second index, third index, and fourth index, which is basically this one. First index is ID, second index is first name, then third index is last name, and the last index, which is fourth, is age. And we are creating a new student object for this row and returning this student object, which will be collected or added to this list. And once all the records have been processed, we will finally get this list as output. So if we print this list and run the program, so we see a student list with 2 items, because we used the query ID greater than or equal to 2, and we have 2 records, second and third, with ID greater than or equal to 2. Now this is not limited to an object. This maprow method, it could be a string. We can simply concatenate all the values and return a string, then we will get a list of string. So maprow is a very useful method that we can use in a project, especially when we have entity objects or simple POJOs. All right. In the last video, we learned about the JDBC template. We saw how to use JDBC template to connect to a database. We saw that we can pass parameters to a query in couple of ways. For example, we can pass the values directly. So like this. So here we are passing the ID value directly in the query. That's hard coded. We can also pass the values dynamically. So this is an example of passing the values dynamically. In this, we are using the placeholders, and it's often the best practice to use the placeholders to avoid the problem or the attack of SQL injection. So what we do, we use the placeholders in the prepared statement or in the SQL query, and then we provide the values relative to those placeholders. Now, if you notice in this prepared statement, we have 4 placeholders, and then we are passing the values of these placeholders one by one. So set int means that we are setting an integer value and the index of the column is 1. So the value of the first column is going to be 3. Similarly, the index of this value is 2. That means first 3, this string value is going to be the value of column number 2. Now, as you notice, it is very difficult to understand what are these column indexes for and what kind of column it is and exactly which column are we talking about. What I mean by that is, if you look at this code, then we have no idea what this column index 2 means. Is it first name, last name, or something else? And what is this column index 1? Is it the ID? Is it the age? So you know it, you get it. It's very difficult to understand, to map the columns. Now, to overcome this problem, Spring provides another template, and that is called namedJDBCTemplate. What it does, instead of using the placeholders like this, then setting the values by indexes, we can give the named placeholders so that it's easy to understand exactly which parameter are we talking about, for which parameter we are passing the value. So it becomes easier to understand. So in this video, we will see an example of named JDBC template. So whatever we did with JDBC template, the same applies to the named JDBC template. The only difference is, instead of instantiating JDBC template when we are using the named JDBC template, we are going to initialize that with the given data source. So all the setup remains the same. That means if we go to the app config, we still need to create the data source. And in the DAO, we will simply create the named JDBC template. So for the sake of simplicity, I'm not going to create a new DAO. I'm going to use the same DAO, and I will just add a new variable named JDBC template and will initialize that in the same constructor. Then we'll use the same template in the existing method. So let's do that. So the class name is named JDBC, named parameter JDBC template, like this. Then same as the JDBC template, we need to create a new object of named parameter JDBC template, like this, and we pass the data source. And in the test queries, let me comment this one. So for now, let's print the object of named parameter JDBC template to verify that the setup is working fine. And let's run the program. And we see a valid value. That means the code is able to initialize the named parameter JDBC template. So now let's use it. Let's say we have to trigger a select query. So the process is same, the methods are same. We are going to use, for example, let's say query for list. Now, if we expand the suggestion, you see the first parameter is SQL, where we provide the SQL, and it is common for query for list, query for map, and query for object. The second parameter, how we pass the named parameters. So a query can have multiple named placeholders, and we need to provide the data or the values for all the placeholders. So how we do that, we create a map of the named parameters and then we pass that map to the query. So we can pass the map, or we can create an implementation of SQL parameter source. All right. So that way we pass the named placeholders and their corresponding values to the query. So let's write a query and let's try to pass the values using named parameter. So select star from students, where we are going to pass multiple values in the where clause to understand how we pass multiple values. So let's say we are going to get this row. So we'll say first name equals to this and last name equals to this. Now the column name is first underscore name. Yes. And instead of passing the placeholder using question mark, what we are going to do is we are going to name this placeholder. So we can give it any name. It must start with the colon and the name of the placeholder. So let's name it F name, and last name equals to colon L name. So now the query has two placeholders, but this time these placeholders have a name, f name and l name. The next thing is we need to provide the values of these named parameters. And to do that, we need to pass a map. So we say spring params equals to new hash map. And we can say something like this, params.put. The first one is f name and the value is this one, and the second placeholder is l name and the value is last two, and then we pass this this hash map to the method. Okay, and this returns a list of map. So let's save the result. String and we can get it printed. Okay, so we can change it for now, and so we see that we get the value back, a single record in this list with first name what we passed and last name the value that we provided using the named parameter. But now if we compare this example with this one, you can see that it's much easier to understand, because here we know that this value belongs to the f name placeholder, which is this one. And similarly for the l name placeholder, we are passing last two, a string value last two. We no longer need to like remember the index of question marks and the index of column names. All right, so that is much easier to understand using named parameters. So now that we have seen we can execute queries like this, passing the named parameters using a map, let's head on to the documentation and see a couple of more ways where we can pass the named parameters. So if we open the documentation of Spring Framework, where it says using named parameter JDBC template, you can see that we can also pass a SQL parameter source. So if you see the example of this query which takes one named parameter, then we are creating a new object of map SQL parameter source, passing the name of the placeholder and the value. And then we can pass this named parameters, which is an instance of SQL parameter source, to the query for object method. Similarly, we can create, let's say, singleton map or the hash map the way that we created. That's also valid, and we can simply pass a hash map. We already saw the example of this one. Next, if we have multiple placeholders, what we can do, we can create a bean, for example a simple pojo, and this pojo will have several properties. Then we can, let's say, create an object bean. Then we can use this bean with named parameter JDBC template. So here in this example, if you see, this is the query that we are going to execute, and there are two placeholders, first name and last name. That means we are going to use a bean and passed the example actor. Example actor is nothing but an object of actor class, this one. And also notice that the placeholders, the name of the placeholders is same as the property names. Now, if we follow this pattern, then what Spring is going to do while executing the query, it will get the values from the object that we passed, because it has already the properties set properly. So it will have some value for the first name and some other value for the last name. So Spring can get those values using the getter methods. So that is yet another way of passing the parameters when we are using the named parameters. So that's pretty much it on the named parameter JDBC template. The methods that we have seen with JDBC template, they are going to remain the same, the overall functionality. So we can use query for object, query for map. We can also use, let's say, RowMapper like this. The only difference is, instead of passing the values directly or using the question mark, we pass the name parameter. All right. So that concludes the data access support provided by the Spring Core framework. Thanks for watching.